Hi, I'm Will. Well, let's make a video game. So here's how I think we should do this. First of all, we can have a player, and there can also be a lot of things, and the player just goes around and avoids the things. Maybe collect some stuff in the middle. I don't know. So I guess that's my pitch. Video game companies, take note. So to make this, we're going to use Webgl. Webgl is a graphics API that runs in your web browser. And it's really, really great because you can make something and then share it with your friends really easily. Here I'm showing you some stuff that people have already made with Webgl. It's been around for a while now, but some browsers have been pretty slow to adopt it. And I also want to point out that it's a little bit slower than if you were going to run your program in native code because it's all tied up with JavaScript. But for most things, it doesn't really matter. Okay, great. So let's just put our excited caps on and just jump right into this. Step 1 when you're making a video game is don't start from scratch. Step 2 is find a library. This is three.js. If you haven't heard of it before, go to three.js.org and it might be worth it to spend some time checking out these examples. Some of them are pretty cool. Anyways, for our project, go and click download. And while it's downloading, I'll explain a bit more about how three.js works. In fact, I think all 3D graphics works this way. I can't even think of another way to do it. So if you're new to 3D graphics, alright, listen up. What we're doing is we're rendering a scene. And inside of the scene, there's a camera, and then there's some meshes. And the meshes are just a bunch of triangles. You can do a lot if you have enough triangles. And the camera is like where the person viewing the scene is, or where the scene is shot from. The camera and the meshes in the scene both have a position and a rotation. And kind of like things in the real world, each mesh has a geometry and a material. In this case, it's a tetrahedron that's made of paper. And then unlike the real world, the camera has what's called a frustum. A frustum is just a pyramid with the top chopped off. The camera will see everything that's in the frustum, but things outside of the frustum are invisible. The frustum doesn't really come up that much. Mostly I just wanted to make a frustum out of paper. Just a good, God-fearing frustum. The final thing is the renderer. After you have everything in your scene set up, you can just give it all to the renderer and it will project all the 3D stuff into a two-dimensional image, and that's what's shown on the computer screen. So those are the basics anyways. I really like 3D programming because there's a real-world analog for a lot of the objects we use. So let's get back to our game. I don't really like starting with a blank document, so let's just find a good example that we can kind of use stuff from. If you get really into this stuff, this example page they have is extremely useful. This one's cool. Okay, so this one looks pretty good to me. It has a thing, and our game's gonna have things, so let's use this. Here's that example inside the three.js examples folder. And sure enough, there it is. If you're having problems getting it to run locally on your machine, you'll probably need to set up a local server. I'll put a link in the description that'll help you out with that. Let's take a look at the code. Yep, it's just as I suspected. All of our friends are here. The camera, the scene, the renderer, and a mesh. So here's the part of the code that sets up the renderer. Here's the part that sets up the camera. The scene is instantiated here. And this part just creates a mesh and then adds it to the scene. So we want our game to have a lot of objects in it. And right now, this scene just has one object in it. So let's put a for loop around the part that makes the mesh and adds it to the scene so we can make a lot of meshes and add them to the scene. So just so all the boxes aren't right on top of each other and so we can see them, I'm going to put all the boxes at just random positions in the XY plane. Okay, let's save it and reload it. Perfect. We're done. First of all, the boxes are too big. So we can go into the part where they declare the geometry to make the boxes smaller. So these numbers here represent the length, the width, and the height. And so let's just decrease them by a factor of 10. Also, the boxes are a little too close together. So I'm going to increase the radius that they're spawning in. And I'm going to make there be a little bit more boxes. So let's see what this looks like. Yeah, okay, this looks pretty good. This is about how the Cheerios were before. I had to try a few different numbers before I came up with those ones. When I'm making games, I usually spend a lot of time just kind of playing with numbers and seeing how it makes the game look. Keep in mind that those meshes are the enemies. The player is supposed to avoid them. It's too easy to avoid a stationary mesh, so let's make them move. And we can do that inside of this animate function. This is kind of where all the action is. This gets called at most 60 times a second due to this request animation frame function. And the other thing in here is the renderer.render. So this means we're drawing the scene up to 60 times a second. So if we want the boxes to move, let's first store them in an array. And we'll call it enemies. And we'll call enemies.pushMesh. We'll set the enemy speed to be 10. Now in the animate function, we can iterate through the array and decrease the y-coordinate of the enemies by the speed. Alright, let's see what that looks like. Okay, it looks pretty fast, but we can fix that. Water has started falling from the sky, and so I think we're on the right track. So one problem is that they fall, and then they're off the screen and they're gone. Right now it's a pretty short game. To fix this, I'm going to add an if statement that says if the enemy's y-coordinate is below the bottom of the screen, then change the y-coordinate to be top of the screen. Okay, let's see what this does. Okay, this looks pretty good. Now we just need to add a player. The player should follow the mouse. So to figure out how to do that, I did a Google search for three.js mouse move example. Here the creator of the library refers us to this example. And then this example shows basically what we want. We can look at the code for this and figure out what part makes the mesh follow the mouse, copy it in, and make it work with our program. A big part of getting this stuff to work is just learning to look at examples and figure out how they've made it work. And so that's what I've done here. Now we need to figure out if the player is in contact with one of the enemies. Probably the easiest way to do this is just change the player and the enemies from cubes into spheres, because collision between two spheres is pretty simple to calculate. You know, two spheres have collided if the distance between their centers is less than the sum of the two radii. So we'll change all the 3.box geometry into 3.sphere geometry, and then in the animation loop, when we're iterating through all the meshes, we'll check the distances to determine if there's a collision. We're almost there. The last thing we need to add is a little gem for the player to go around and collect. I created the gem in pretty much the same way I made the enemies. And then down in the animate function, the collision detection is the same. And I've also added a score, which I just did in HTML. And then if a player collides with a gem, increment the score by 1, and then put the gem at a new random location. And then I said if the player collides with an enemy, set the score back to 0. And that's all there is to it. Here's the final game. It ended up being just under 50 lines of code to get to this point. Oh, whoa, close call. It's pretty fun. I've played it for about 30 minutes now. The best I can do is 36. I kind of lose focus after that. And I ended up putting it in a smaller container on the web page just so it would look nicer and be the same on everybody's computer. But there's a lot that could be done to make it better. I mean, for one thing, it just looks awful. It could really there's a lot that could be done to make it look better. And that was nice. And the high score list would be kind of cool. Also, maybe every time you collect a gem, the difficulty would increase a little bit. Oh, I hate it when it's at the top. Whoa, snatching it away like Indiana Jones grabbing a totem. So I hope you guys got something out of this video. Most of all, I hope you're excited to go out and just try to make a game of your own or experiment with my game. I put the code up on GitHub, and You can play it live at will.ninja/meteors. I ended up calling it meteors, even though it's like little spherical boxes, but whatever. I'm doing 25. I'm doing pretty well. Let me just finish this out, and then I'll close the video. I got a All right. Well, thanks for watching.